And so I was going to start by sort of thinking about, I guess, about what's special about education in England. And all my experience is in the state sector, so it may be that I slightly off balance on the private sector, but I actually think that the things I'm going to say are common to both. I think there are some very special things about education in these damp islands, and they are things that I would really not want to lose. The first thing is that children in England are expected to enjoy primary education. Would you agree? It is a cultural expectation that children are happy going to school, that they enjoy primary education. Indeed, if they're not happy coming to school, you know, their parents are beating a path to your door, are they not? They're going, Jimmy's crying on the way to school. And you can't say, well, tough, so am I. You know, that's not an acceptable answer. Actually, you have to take it seriously, and you do take it seriously. And we pride ourselves on the fact that children do enjoy primary education, that they feel valued, that they feel safe, that they feel like education is something in which they are participating and not something which is being done to them. Would you agree about that? I think that is an incredibly valuable attribute. I would hate it if we lost that. It's one of the things that makes us distinctive, and it's one of the things which we are world-renowned for. The other thing is this, and this gives us a very different feel from Shanghai or Singapore. We are an open democracy, and our classrooms are extremely diverse places. The children we have a lot of difference in the class. So it's the case that, put up your hand if you can say with complete honesty that all the children in your class are, mathematically speaking, at the same level. Well, I'm looking across the state sector and the private sector, and I'm not seeing any hands. So I think that says a lot, does it not? Are they, mathematically speaking, at the same level? No. We have a lot of variation, we have a lot of diversity. We do not have homogeneous classrooms, do we? On any criteria you go and throw in. I think that's a massive strength. It also makes the job quite challenging, but not boring. Because we are, you know, dealing with lots of different abilities, interests, cultural backgrounds, differences. That's all what makes up education in Blighty, isn't it? So I take those two things as a given. We have diversity, and we're proud of it, and children enjoy primary education. And I think those two things are massive strengths, and we should, no amount of long division is worth losing either. I'll say that very candidly. So, what does teaching for understanding mean in this context? Everybody says, oh yes, we need to teach maths for understanding. That's really important. And we are reassured that those in Shanghai and Singapore also believe the same thing. However, I think that teaching for understanding here in England means something rather different. And that's what I want to tease out today. And then I want to move on to consider the question, is it necessary to have a blocked curriculum in order to achieve mastery in maths? So those are the two questions. What is it in England, or Wales, or Scotland? What is it to teach for understanding? And secondly, is it necessary to have a blocked curriculum? So, teaching for understanding, in order to get to grips with this, I need you to do a little bit of maths. It won't be hard, so don't leave. It will be quite easy. And what I'd like you to do is work with your maths partner, who is the person who happens to be sitting next to you. If you're a really difficult sort of person, you can work in a threesome, because it'll kind of dilute you. So I want you to work together. No one is to set pen to paper. This is not the sort of maths where you need to set pen to paper. It's all to be done in your head. And I'm going to put 4 calculations on the board. I will read them out as I put them up. And those calculations, I just want you to talk to your partner about how you would do them. What strategies you would need to do them. As I say, they are not very hard. 121 minus 78. 121 minus 59. 121 minus 4. And 121 minus 20. You'll see there's a bit of a theme going on. Right, off you go. You've got a minute. Okay, so some years ago I developed the concept of the no-work sum. That is a calculation where you do not have to expend a single calorie in order to do it. If you are expending any energy, something's gone badly wrong. One of these is a no-work sum. Which one is it? Yes, indeed, it is indeed the last one, because this one, actually, you shouldn't be having to think about it at all. You should be thinking 121 is 120 and 1. And therefore, if I drop the 20, I get 101. So if you're having to do any work, it means you don't understand place value. Yeah? Are we agreed? And if you understand place value, you don't have to do any work. So we can kind of take that one away because actually that one doesn't require us to do any subtraction. What we're basically doing is understanding place value. Okay, these 3, which one do you think is the most difficult? Most tricky? Yeah, it's a difficult question, isn't it? Let's have a vote. It's like Switzerland, you have to vote. All right? So put up your hand if you think the top one's the most difficult. Oh, a very clear majority. Put up your hand if you think the second one. Okay, put up your hand if you think the third one. Okay, yeah, I'm a bit on... I'll share this with you. It's interesting, isn't it? Because the one that will get the most errors, undoubtedly, is this one, because quite a few of your class will get it wrong by 2. Do you understand why? Because I always start by pointing out to children that this is a nearly number. We develop the concept of a nearly number in year 1, don't we? Where we're looking at the 1 to 100 grid and all the numbers that are nearly a multiple of 10. So I say to my year 1s, 29 is nearly... Well, you're just nowhere near as good as my year 1s, but I'll let it go. So so we develop the concept of a nearly number right in year 1 so that they really get to grips with that. And here I will be using that concept, won't I? And we'll take off 60, which is really very easy because it's half as well, so it's easy. So the answer is 61, but now I have a little crisis. And the crisis goes, do I add 1 or do I take 1 off? Do you know where I'm coming from? And half your class will probably go the wrong way. And that's why it will get the highest number of errors. But I like to teach, because I know that error is going to happen, you can teach away from it. You can address it before they fall into it. I call these it's not fair sums. And the reason it's not fair is because you've got £121 or stickers and you've got to give me 59. Well, I take 60. What are you going to say? It's not fair. So what do I have to do? Yeah. And once you get that idea, it's quite easy to remember because it's an it's not fair sum. So, okay, this one, strictly, we do by rounding and adjustment. We round and adjust. And it's a very efficient strategy. And we use it in all sorts of things. And we use it routinely without even thinking about it in daily life because all the flipping prices end in 99. And you don't even see that. I say, how much is it? And you'll say, oh, it's 25 quid. It isn't, it's £24.99. Do you see where I'm coming from? So we're very used to nearly numbers, aren't we? Let's have a look at this one. This one is quite a tricky one. Can a couple of people tell me how they and their couple, with their partner, did this? Let's have a few people in the, yeah.
We looked at counting out from 78 to 100 and then on to 121.
Right, this is a strategy which you may or may not know, technically is called a Gesupter. Gesupter. Yeah? A more common name for it is shopkeeper's addition, because it used to be the way that, in the old days when we didn't pay with a contactless, it was the way that shopkeepers gave you your change. And some people here obviously remember this. So paying your milk bill, you know, it was £3.21, and the milkman would say, well, 9p makes it 30, 70p makes it £4, and £1 is your fiver. Do you see what I mean? Does anybody remember that? And so shopkeeper's addition, because the way shopkeepers subtracted was by counting up. Let me just say a few things about this. It is always easier to count up. Even with almost any subtraction, and definitely with decimals or money. And with this one, if you're using Abacus or Hamilton, you'll probably call this frog, because we call this frog, this method, and I can see some people nodding. I let the children do a few frog hops before they start doing these, so they get very good at them, the frog hops and the maths. And so, as you say, we count up to 100. Now, if you're in year 3, this may be what I call a two-hopper. I may count to 80 and then to 100. But if you're in year 4, I would really hope it was a one-hopper. And I know that that's 22. Obviously, it could be 2 and 20. Are you with me? So it could be 2 hops. It could be 1 hop. And then I go to 121. I should not be doing any work there. That is a no-work hop, because it's really only about place value. And so, actually, this becomes extremely easy. The answer is very easy to find, yeah? Well, we agreed. And that counting up strategy is much easier to do in your head than the much more complex column subtraction, which, if I don't let you write anything down, is going to be hard here, isn't it? If I don't let you write anything down, you wouldn't want children doing a column subtraction in their heads, would you? It would be incredibly error-prone. Some years ago, children were given the calculation 2003 minus 5 in the international tests, and what all these lovely 9-year-olds did was write down 2003 minus 5, and off we go on our columns. Do you think that's a good way of doing that? It's incredibly error-prone. Why? Yes, because you're going to have to do a lot of transferring in order to make it work, a lot of decomposition. How did people do this one? Counted back. Did you count back in ones? Yes, some people did. That's quite sensible, because 4 is a very small number, so I can count back. But some people may not have counted back in ones. What might you have done? Yeah, taken 1 off and then taken 3 more. We call that bridging 10, because we say, well, 1 off 121 is 129. I need to take 3 more off. And I'm using a number bond, am I not? 3 off 20. So this one is a counting back, and it also uses number bonds. I doubt many people know their number bonds to 21, but we do know our number bonds to 20. So that makes it a bit easier. Now you've got 4 different subtractions there, and you have done them in 4 different ways. And it would be clinically insane to do them all in the same way. Do you see where I'm coming from? And this indicates something really important about teaching maths. And that is that you are, when teaching maths, of course, teaching skills. And that is quite true. And I like the focus on teaching skills that we have at the moment. I think it's useful. And I think, by and large, I see skills being taught really well. I will come back to that. But that is, if I may say so, the easy bit. The much harder bit is allowing children to develop metaskills. These are sometimes known as the higher thinking skills, or the higher cognitive skills. And these are what it's very difficult to get children to acquire. The reason being that I can directly teach a skill. I can teach children how to count back. Okay, put it in your head, 21, 20, 19, 18. You know, we all do it, don't we? We look like idiots. With the reason being that we actually want them to go 21, 20. We don't want them to go 21. You see what I mean? So we can demonstrate a skill. We can model it. And you can directly teach it. You can't directly teach a meta skill. A meta skill is knowing when to use the skill. Do I count back? Do I count up? Should I do this one by rounding and adjustment? Should I do it by counting back? Now, you all knew which method to use. How did you know? How did you know that this one was quite a good one to count back and that one was quite a good one to do a rounding strategy? How did you know? What did you look at? What gave you the hint? You looked at the numbers. You looked at how far apart they were. 4 is very little, 121 is really big. You looked at how close together. You looked at the type of number. That's a nearly number. So you studied the numbers. In order to acquire meta skills, you have to be able to choose a strategy or a method. It is vital. This isn't the icing on the cake. This is not something you can do if you want, but not otherwise. As long as you drill the skills in, it won't matter. This is essential if the children are to develop error-proof ways of doing calculations, either in a test situation or, much more importantly, in everyday life. Our job is to produce numerate children. I don't think none of us would disagree about that. We need them to be able to choose a strategy. But it's actually worse than that, because not only do they have to choose a strategy, they also have to be able to choose an operation. By which I mean, so I am an infant teacher, as many people here probably know, and that's all good, but I teach 1 day a week, and the teacher who shares the class with me obviously teaches 4 days a week. You probably are thinking that they've got the short straw. You're right, they have. Normally I teach in the infants, but at the moment I'm teaching in year 4. It's a bit of a stretch for an infant teacher, isn't it? Has anybody else done that? It's quite funny because all the parents come up to you in the playground and they go, "You've done well. You know, that's really good. He must like you," because they regard moving up as being promoted. Do you know what I mean? Next year when I go back to reception, I know very well they're all going to come up and go, "Oh, what a shame." You know, how sad. But anyway, teaching year 4s, which as I said is a bit of a stretch, coming in after Christmas in January, and you know, we've all got Christmas brain, haven't we? Coming on the first day of term after Christmas, and on the board I put to get our togethers going, you know, after Christmas. Right, how many of my lovely year 4s do you think subtracted 18 from 58? How many do you think? Well, I'll tell you, it was all of them. I was going ballistic because every single one of them fell into the trap prepared. Do you think yours would do the same? Even without Christmas brain. What I wanted them to be saying was some very big number has 18 taken off it and you've still got 58 left. That's what I wanted them to be saying. That wasn't what they were saying. What they were saying was, I've got 2 numbers and a subtraction sign. That's what they were saying. Do you know where I'm coming from? Oh, good. At the same time as I was suffering these agonies in year 4, my very lovely colleague in year 6 was suffering similar agonies because he had put up a SATS problem. I mean, that's a typical SATS problem. But he had put up a SATS problem and it went like this. It went, Sam earns a wage. He's a very good boy. And so he gives half his wage to his mum for board and lodging. And his mum gets 82 quid. How much does Sam earn? Do you want to know how many of the year 6s wrote 41? Yeah. He also was crying into his coffee cup at playtime. And the reason we're both crying into our coffee cups is because what you've got is, I've got a half, I've got a number that looks eminently like it can be halved. And so I fall into the trap. I've got a number and I've got, you see what I mean? That's not a subtraction. That one needs doubling. You have to choose an operation. It is not enough to be able to do subtraction. You have to know if you need to do subtraction. Or whether, and if you do need to do subtraction, how do you need to do it? What method do you need in order to do it? But it even gets worse than that. So there was a very important study done by the Institute of Education in London. It was called the Maths in Work study. And one of the things they looked at was the way nurses and health professionals used numeracy in their general work. One of the rather scary findings was that when nurses or others make errors, numerical errors, they are not calculation errors, they are place value errors. So if a nurse gives you the wrong amount of a medication, it is likely to be 10 times too much or 10 times too little. Does that console you? It shouldn't. Ever since I read the study, I've been paranoid about checking arithmetic. So now I always check the arithmetic. One of the problems that the nurses were given went like this. It went, the medication has to be diluted, okay? And it's diluted on a 5-to-1 basis. So 5 amounts of water to 1 amount of medication, okay? So the question is 1/5 of what you give the patient medication? What do you think? The question is what you give the patient, is the drink you give the patient 1/5 medication? No, you all sound pretty sure about that. Okay, so the second part of the question, it would probably upset you to know that the nurses all said yes. But the second part of the question is this. Okay, I've got 20 millilitres of water. How much medication do I need to put in? Well, if the answer's 4, and I'm not giving anything away here, 4 is 1/5 of 20. Does that give you pause for thought or not? Can you explain that to me? Yes, exactly. How much it is 4, you're absolutely right. How much medication am I giving? I'm giving 24. And 4 is 1/6 of 24, and you were quite right, it is 1/6. Now, can I just say, that is hard, isn't it? If I stop somebody in the street outside in Reading High Street and ask them to do this, do you think they'd be able to do it? Certainly not off the top of their heads. When do children have to do this? Age 10. That's what we are asking of children aged 10. Am I right? Yes. So not only do we have to choose a strategy, we also have to be able to choose an operation. Not only do we have to be able to choose an operation, we have to be able to solve problems. And those problems are quite often in a context. And the context may be a word problem, or it may be a real life problem, or it might be geography, or it might be history, it might be anything. But we have to be able to solve problems in a context. Now, this has repercussions. And it has repercussions because all of these things involve something quite important. They involve decision making. They involve making a choice. And the thing is, that is scary. Children love it when you tell them what to do, especially in maths. If I tell you what to do, I want you to do this. I want you to add the first 2 numbers, then I want you to do a subtraction, and then write the answer. You will be very happy, because you'll be like, yeah, I can do that, that's fine. But when I say to you, it's not clear what you have to do, here's the problem, it gets a bit nerve-wracking, doesn't it? And lots of children, don't they, find that very stressful. Do you agree? Yeah. How can we make this not stressful? How can we make it something that children get good at doing? Because in order for them to develop these meta skills, we have to do this from the word go. From nursery reception. Children have to be choosing a strategy right from the beginning. And that means, and I will come back to this when we talk about blocking, but that means that I might do, obviously my teaching is on a skill. I am teaching a skill. So supposing I'm teaching frog, gazuptas. So I'm teaching you to do things like, I don't know, 13.2 minus 8.78. Now if I've been doing counting up subtractions ever since I was in year 3, then this immediately shouts 22 at me, doesn't it? You with me? So if I know that 22 I'm going to get to 9, 9 to 13 is 4, so it's 4.2 plus 22 pence, 4.42 pence. I can do it in my head. You with me? I can certainly do it with a jotting. I do not want children doing that as a column. What am I scared they will do? Especially in exam conditions. What do you think they might do? Line it up wrong. And that's going to be a disaster, isn't it? And also the understanding which says, look, 22 pence takes you to 9, is a very useful understanding. And so supposing I'm spending a week teaching counting up subtraction. You know, here we are, we're doing counting up subtraction. You've all been hopping up and down being a frog. You like the ribbit bit. Then I've got you to hop along, you're going to the next 100 and to the bigger number. You see what I mean? You're all getting really good at it. We're all getting a happy feeling in our tummies. It's all good. Then what happens is, sort of, I do that for 2 or 3 days. Now, on those 2 or 3 days, the starter for the lesson is also subtraction, but it's not counting up. On day 1, the starter is 121 minus 4. It's counting back. Because I want to remind you that sometimes we subtract counting back. You learned that when you were a bit younger, but we still can do it. On day 2, the starter is 121 minus 59. Because I want to remind you that sometimes we round and adjust. And on day 3, the starter is place value subtractions. And then on day 4, I don't teach you counting up subtraction. I've done that. What I do is I give you 20 subtractions on the board. I say, work with your partner. What you have to do is decide how to do each one. And I'll tell you right now, they're not all frog. Only 8 of them are frog. So you've got 20 there, you've got to decide which 8 are frog. And what are the others? Do you see what I mean? And having that discussion is really important because I am forcing you to make a decision, to choose a strategy. And only if I do that will you start developing the skills of knowing the higher level skills of knowing when to use counting up, when to use counting back, when to use rounding. But in order to make you comfy with this, I have to do something that is very important in primary education. And we all know that it's very important. It is play. I have to allow children to play with numbers. Because only if they play with numbers, if they find numbers playful, will they be able to be not scared when you're not telling them what to do. And so this is not as hard as it sounds. With my year 4s, when with my year 4s I am going, okay, I don't know what it is. I'm not having taught year 4 in a very long while. It came as a shock to me. When I had those same children in year 2, they could all add 2 two-digit numbers without any problem at all. You gave them 2 two-digit numbers, they could add them. They didn't draw columns, they could add them in their heads. They counted on in tens and then added the ones, or they partitioned them, added the tens and then added the ones. Do you see what I mean? Some used one method, some used the other. They were very confident it was all good. By the time we come back to year 4, I get them in year 4, you give them 2 two-digit numbers and they all draw a little column addition. I'm going mental. I'm going, what are you doing? You can add 2 two-digit numbers without writing anything down. Why are you writing? Oh, we like this. They were like, oh, I'm like, no. So I think to myself, we've got to get the fluency back. Anybody should be able to add any pair of 2-digit numbers without writing a thing down. So I'm like, okay, so what I want to do is give them a page of 20 two-digit plus two-digit numbers to do. But that is very boring, and it also does not address the Metaskills. So what I in fact do is this. I draw a little grid on the board. I put some numbers in it. I say to them, right, I can generate two two-digit numbers, 21 and 38. Is everybody happy with that? I can add those without doing a column addition, all right? Now I can generate two numbers by reading down. 23 plus 18, and I get another one. And if I add that and that, I will get 100. Okay? If you don't believe me, try it and see. All right? What other 4 digits could you put in this grid such that you get 100 at the end? Now, because children are a bit nervous doing this, I use a very simple technique. I say to them, okay, it's a little bit scary. You've got an empty grid, and I'm saying, what 4 digits are you going to put in it? Tell me a really stupid suggestion for this space. What's a really silly suggestion for this space? Somebody give me a really silly suggestion for this space. Why is that a silly? That's a brilliant, stupid suggestion. Tell me why it's a brilliant, stupid suggestion. Why is that a brilliant, stupid suggestion? Why is 9 in there not going to work? You'll get 90 and 90, and that's not going to give you 100, is it? So, okay, so now I've made you give me a stupid suggestion, you can start thinking about what a good suggestion might be. Do you see where I'm coming from? So I quite often ask children to give me a silly idea, because then they can, when they give you the stupid idea, they can start thinking about what the clever idea might be and work together and think about, within 5 minutes of giving them this, they will be adding two-digit numbers all the time, but they will also be saying things like, look, you can't have anything bigger than a 5 in this space. Actually, miss, this one always turns up twice. Miss, if you add that one and that one and that one, they all have to come to 20. I'm like, oh. Right. Now, those sorts of statements are all about thinking, reasoning, problem solving. They're all about this, aren't they? At the same time as I'm doing that with my year 4s, the day before, or actually probably the week before, we had done a similar thing to get them to subtract two-digit numbers, because I find similar thing. They lose their fluency. So I said to them, okay, write I'll do this with you, it doesn't take a second. Write a two-digit number on a piece of paper. Really quickly. A two-digit number. The digits must not be the same. Reverse the digits. Find the difference. So write a two-digit number, reverse the digits, find the difference. Okay? Shout out some answers. I only want the answers. I only want the difference. Shout out a difference that you've got from yours. 9. Okay. Another one? 18. 45. Go on. Another one? 27. 36. What do you notice? They're all multiples of 9. And what's interesting is there will be a couple of people in this room, I'm not going to ask you to stand up, who didn't get a multiple of 9. I bet you did it wrong. So have a look. And that's exactly what happened to the children. They started shouting out answers, and then they were going, yours is wrong. And it was very good tempered, it was nice, but we were all, so I said, well, does it always work? Can you find one that doesn't work? Try some extreme examples. What happens if you take 90, etc.? And then we said, all right then, fine. What about a 3-digit number? Does it work if you have a 3-digit number? And so forth. And so, within 5 minutes, they are discussing why this might lead to this. What happens with 3-digit numbers? It's different. Why? These things, at the same time, my colleague in year 6, the one who'd cried into his coffee cup, he was doing things like this. Okay. No, he was trying to practice mental multiplication, but not column, not long multiplication or short multiplication, using mental strategies in year 6 in multiplication. So he's getting them to do things like 9 times 19, but he did not want them to draw a long multiplication or a short multiplication. He said, no, come on, we can do this. It's a nearly number. So if we do 9 20s, that's easy, you can do it in your head. What's the answer? Yeah, 180. But I've got to take 9 off, haven't I? So 171. Do you see where I'm coming from? So if I then do 9 times 29, what will we do? Yeah, we'll do 9 times 30, and we'll have to take 9 off. So 9 30 is 270. Yeah? Are we all happy? So take 9 off, 261. Let's do 9 times 39. 9 times 40. Any offers? 360. Take 9 off. 351. What do you think the answer to the next one is going to be? I might as well put the first one in. 441. What do you think the next one's going to be? 531. And the one after that? And the one after that? And the one after that? Sorry, it's 711. I beg your pardon. And 801. Now you're stuck. Now you've got to go away and do some work. Do we know what the next one's going to be? Well, we could have a hypothesis, couldn't we? You might already have a hypothesis. But then I'm going to make you do it, and I'm also going to make you check that these were correct. Do you see where I'm coming from? You're doing a lot of practice, but you're doing the practice in the context where you are actually developing the meta-skills. And that is the key. No teacher nowadays can tell me that they cannot find these playful activities, these investigations, these problem-solving activities. On Hamilton and on Abacus, for every single week when you are teaching a skill, there is an accompanying investigation. So all you have to do is look and you will find a playful activity which practices that precise skill. There's Enrich, there's NCETN. There are loads of places you can go to find this type of activity. I'm not saying you never give a page of sums. Of course you give a page of sums. I give a page of sums, you give a page of sums. It's necessary. But it's also necessary to put children in a situation where they're making a choice. And it's necessary to put them in a situation where they're playing, where numbers become playful, where they gain confidence, because without confidence you cannot make decisions. And that play is absolutely critical. Now, I said I would come back to the teaching skills, and I will come back to the teaching skills because it is quite important. There's one word which is important when we talk about teaching skills, and that's consistency. And consistency in relation to two things. In relation to the models and images that you are using, and in relation to the layout. Now, everybody uses models and images for teaching, but the problem is that we tend, because we're so busy and so stressed, we tend to shut our classroom door and use the images and models that we particularly like. So what happens there is that, this lovely lady here, she's teaching in year 1, and what she does is she really likes to use her Numicon, because she went on a Numicon course and she got a free pack. So ever since then she's been using her Numicon. Well, when they go up into year 2, she did not go on the Numicon course. She's quite miffed, actually, you can see. She didn't get a free pack. She's not very happy. She doesn't use any Numicon. She uses number line. She's very wedded to her number line. That's great. But when they go into her class in year 3, no. She trained in Sheffield. She likes the arrow cards. It's not number line in sight in her classroom. She uses Dean's blocks and arrow cards. That's it. Then they go into year 4. Well, she doesn't like you see what I mean? It's haphazard. All the models and images I have just mentioned are brilliant, are they not? But you need a developmental approach to the models and images through the school. Each model, each image has to be developed through the school. Some are linear, and they're very useful for things like counting up. Some are non-linear, like Numicon, which are very useful for number bonds and doubles. Some, like Deans, are very useful because they show the structure of numbers, like place value. But you know, without consistency, even that is useless. So what happens in a lot of schools? You know, in year 2, we introduce the place value equipment. And what we do is we say, you know, this little cube, it's 1, and this nice rod is 10. And here we have 100 in a square, yeah? Is that right? And, you know, children cotton onto that, and they understand that 121 is one of those squares, and then 2 rods and a little cube, and that's all very good. And then in year 4, when the children have had 4 years of this, in year 4, one fine day, in comes the teacher. She holds up those exact same equipment, and she says, you see this square? It's 1. Well, the children are like, what? You see this rod? It's a 10th. Now, the children have had 4 years of being told it's 10. There's not a single child in the class hears the on the end of that. They're just like, yeah, we know that's 10. And she says, you see this little cube? That's 100th. And the children think she really has lost the plot. You know, I've had 4 years of being told what these are. Now, no wonder that's confusing, is it? No, it is a very good model for decimals. But it's not a good model if you spent 4 years telling them what those represent. Are you with me? I've got 6 children, hence the grey hairs. And 3 of them are in teaching. That's quite good, isn't it? 50%? Not bad. One of my kids came home and she said to my husband, who's a carpenter, Dad, you see this little cube? He said, yes. She said, I want you to cut it into 10 pieces because I need tenths. And he was like, what? And she said, but Dad, could you possibly do it so they're all the same size? He didn't get it. He didn't do it. I will just say that. It is really important that you are developing these through the school. It is no good if we just shut our door and get on with it, because it's not going to work. And the same is unfortunately true of layout, because actually, in terms of how we lay out our calculations, that can be equally confusing. So on Hamilton and on Abacus, we lay out addition, 530 and 8, plus 200 and 80 and 6. And we lay it out in what we call expanded form, before we start doing it in compact form. But in either event, I always leave a line between the numbers and the answer. Why? Because otherwise, where are you going to put the carry digits? You can put them in here. Well, they get muddled in, and all the untidy boys can't do it. You can put them up here, but they forget them. So there's a risk. You can put them down here. Well, they definitely forget them. But also, it's not a small 10. Why are you writing it small? That's very confusing. If I leave a space, it's nice and easy. 8 and 6 are 14. That's 10 and 4 more. Okay? So 30 and 10 is 40, and 80 is 120, so that's 120 more. See how the place value is explicit. Now, I'll let you into a little secret. We do, of course, move fairly rapidly to compact column addition. I'll let you into a little secret. Actually, if you ignore this, and some people do, and you go straight to that, you will probably get roughly the same success rate in relation to column addition, which is a pretty successful algorithm. Kids can do it. You'll probably get the same success rate as if you do this first and then that. So you might say to me, well, Ruth, then why have you made us go to all this bother of doing this and then that, when actually I can get more or less the same success rate by just doing that? And I'll tell you why. It's for 2 good reasons. Both of them I am mindful of thinking ahead. If I do this, I ensure that every single child understands the place value and that they see that this is not 3. If I go straight to compact, they will say 3 and 8. Listen to them if you don't believe me. So doing this ensures that every child understands the place value. Now, you don't have to understand place value to do column addition. But I do need you to understand the place value for other reasons. Because if you don't, I'm going to get into real trouble in year 4. I can say this truthfully. So I need you to understand the place value. So I make you, even though you're really good at column addition and you've come in knowing how to do it, I make you do this. And if you can't do this, I'm worried. In order to tick mastery for column addition, it is essential that children can do that, and not just that. Because this shows me that you understand what you're doing. Secondly, I know that sooner or later, sadly, I'm going to have to do this. 523 minus 286. Column subtraction. Now, when I come to teach column subtraction, I have to do it in expanded form first, with Dean's blocks or place value equipment. If I don't, I will get a very poor success rate. The evidence is unequivocal. So I have to do this first. Now, if I've done that, I do this in addition. You all move seamlessly to this. You're all very successful. You've all got a very good feeling in your tummies and a warm, cuddly feeling. And so when I come to throw this at you, you're thinking, well, I did it before and it was fine. I know what this layout looks like. It's all right. Last time I did it, I was really good. So you're in the best possible place to start doing the much harder column subtraction. Does this make sense? Thinking ahead is really important in maths teaching. I teach a secondary group every year for my sins. And I always give them a little numeracy test at the beginning of the year. It's year 11, so they're doing their GCSE that year. I give them a little test to start with to see how bad things are. I don't expect much out of the test. I am always disappointed. One of the questions is this. What do they all write? All these delightful 15-year-olds, what do they all write? Yep, you've got it. 3.40. What are they doing? Yeah, and my secondary colleagues say to me, they say, Ruth, can you please tell your primary colleagues not to say add a 0? I say, we don't say that. We never say that, but we don't teach away from it. And that's the problem. When in year 3 you are teaching multiplying by 10 and kids are doing 13 times 10 and 34 times 10 and 68 times 10, etc., you know, and she and I are doing our sums and we're very good girls and we're getting on with it, and we write 13 times 10 equals 130, 34 times 10 equals... And after doing 2 or 3, she says to me, Ruth, these are ever so easy. All you do is stick a 0 on the end. You don't say it, but they do. And that's because you are not teaching away from it. Actually, what I need to be doing is making the year 3s who don't need it do those on the place value grid. Because if they do those calculations on the place value grid, 34 times 10 is 340, they will see that the digits move. If they are writing those calculations on the place value grid, they don't need it, but they must use it. Because then they will see that the point doesn't move. That's the point, it's a point. The digits move. And once you have understood that, you don't make that error. So we need to use the place value grid before they need it. And while I'm on the subject, what are your headings here? Are your headings 1s, 10s, 100s, and then the next class, they're HTU? But then when they go to Athena's class, they're back to 100s, 10s, and you know, is it consistent? Have you discussed it? Are you losing children because they are muddled? And what's the heading in this column? And that's a serious question. What do you put in this column? Personally, I like to put tenths, because none of my 15-year-olds know what that is. You see where I'm coming from? So consistency in relation to models and images is absolutely key. and in relation to layout. If you are not consistent, you will lose children. They will get muddled and they will not understand what is going on. And that's a shame, because you're not teaching any worse. You don't have to teach any differently. You just have to have a staff meeting when you decide how are you laying things out. How do you develop these things? Where do you start developing the number line? The number line is probably the single most important image that we give children in primary education, isn't it? Where do you start using a number line? Tell me. Yeah, reception, foundation, nursery even, yeah? One of my children is an early years expert. She's very, very good. And a couple of years ago, she came to me and she said, "Oh, you must come in and see, Mum. We've got a new outside area. It's amazing." I was like, "Oh, all right then, I'll come in and see." So I go in and see, and she's got a lovely outside area. It's beautiful. But I look around the classroom and I say, "But Annie, where's your number line?" She says, "Oh, Mum, you should see we've got an interactive whiteboard. It's amazing. On there, I said, hang on. The interactive whiteboard is not always on. And if it is on, it's not always on maths. And even if it's on maths, it's not always on numbers, a number line. And anyway, they're very little children. I want them to be handling those numbers. I want them to be pegging them up on the line. When they come in the morning, I want one of them to have fallen off. And I want the children to be going, 7 is missing. You know, or 2 and 5 are swapped. Oh, that naughty puppet. We're going to have to do something about him. It is more important that 4-year-olds can place 4 between 3 and 5 on the number line than that they can count 4 things. Both things matter. But, you know, so I said to her, "I'm sorry, no number line, no Sunday lunch, take your pick." You know, the number line was up. Not a problem. So the fact of the matter is that actually this bit, it's actually not the hard bit. That bit's the hard bit. But don't think that this bit is the bit you can ignore, because it's not. I mean, there are 2 reasons. One is numeracy depends upon this bit, because you need to be able to choose error-proof strategies to do calculations so you get them right. From your perspective, or from my perspective, I actually also need the children to pass the tests. And the tests will have calculations where they need to decide. They will. So if they cannot decide, they can't do it. So that's actually a sort of, if you like, a pragmatic reason. But the more important reason is actually if children play with numbers from the word go, they get comfy with numbers. And if they get comfy with numbers, they can do anything. It's actually much easier. Now, let's look at whether or not we need a blocked curriculum. So the notion of a blocked curriculum is not new. It's usually put as if there's a dichotomy between a blocked curriculum and a spiral curriculum. That's not strictly true, is it? Because a spiral curriculum is usually quite tight. You revisit quite often. A blocked curriculum, you do revisit. No one teaches addition and subtraction only once in 7 years. So you do revisit. It's a question of how fat the spiral is. Do you see what I mean? How long before you revisit? Am I making sense? A spiral curriculum was very much based on the work of Jerome Bruner, which itself was based on reading Vygotsky and the notion that you scaffold children's learning, and that scaffolding means you revisit. When I first came into teaching, I was teaching in a school down at the World's End. That is literally true. It was in Fulham. It did feel a bit like the World's End. But in any event, teaching in that school, we had a blocked curriculum. And this is how it went. You came in, and in September you did addition, which is a nice thing to start with, isn't it? It's quite good, especially if you're an NQT. So you come in and you do addition, and that's all good, and you sort of motor along with it in a gentle, happy fashion, and somewhere around half term you change and you start doing subtraction, which is a little bit harder, but that's fine. And then about the end of November, you stop doing that and you do shape because of Christmas and stars. So that's fine. So you all do shape. And then you come back in January and you start doing multiplication, and that's all right, that's fine. If it's a short term or Easter is early, you never get to division. If it's a long term, you might get to division. But division's a bit hard. We don't really mind if we don't get to it because it's a bit hard. So anyway, after Easter you come back and obviously you do measures because of summer and wet maths. So, it was good. Then what happened was that in June you taught everything again really fast for the tests. Because they'd all forgotten everything that went before. Does anybody remember these days? I can tell you, it didn't work. We realised very early on it didn't work. The spiral really came in with the national numeracy strategy. I do not mean the primary national strategy, I mean the national numeracy strategy, the blue and yellow folder. Does anybody remember this? It actually produced, 1996, the single biggest improvement in the international tables that England has ever sustained. We went from being something like 84th to 5th. So there was a massive improvement in numeracy across Britain with the national numeracy strategy. And very interesting, it was quite a tight spiral. I mean, we were told, those of us working on it, Anita Straker ran it, some people may remember, and we were told you have to revisit place value twice in every half term, because it's so important. You have to revisit addition, subtraction, multiplication and division twice in every term. So once in every half term. So it was quite a tight spiral. Some people are nodding, they probably remember this. Since then, we've had, tighter spirals, looser spirals, all sorts of things. It's interesting, isn't it? The argument for blocks goes, well, you can allow a topic to bed in. You spend time on it. Now, I do think there's an element of truth on that. You can spend some time on one topic. But I would ask you to remember that actually a topic in maths is rarely one thing. If I go in to watch a teacher teach, or to help a teacher teach, or to support, and I say, what's your lesson on today? And she says addition. Well, let's say she says subtraction. I'm going to say, great, subtraction. Are you doing counting back? Are you doing counting up? Are you doing rounding and adjusting? Is it place value subtractions? Now, those are all 4 different lessons, aren't they? They're 4 different skills and they're 4 different lessons. Are you with me? They're not one topic. They're 4 topics. So the problem is that addition and subtraction is not one topic in maths. It's likely to be 7 or 8 skills. And then when you throw in decimals and fractions, it's likely to be 12 skills. Also, it is a fact that we here have the most crowded maths curriculum in the world. It is incredibly crowded, is it not? You do not have long enough to spend on anything, do you? I'm afraid that chopping it up into blocks doesn't give you any longer. If I can allow 3 weeks on addition and subtraction in year 5, then I can allow 3 weeks on it. It doesn't make any difference whether I do those 3 weeks all together or whether I chop them up and do one in each term. It's still 3 weeks. And when people say to me, oh, I'm spending longer on something, I always say, what are you leaving out? Because if you spend longer on something, you are leaving something out. There is only 2 teaching terms in year 6. So you have very little time. We have a very crowded curriculum, you have very little time. Whether you block it or whether it's in spirals actually doesn't make any difference to the amount of time you've got on something. It does make a difference to how you do it. And one of the things that's important to think about is the question of memory. Because the problem is that memory in these damp islands is our short suit. And that is not because of teachers, it's cultural. So let me give you some examples. When I first came to school, and this is practically in prehistory, when I first came to school, I probably knew at least 10 or 12 nursery rhymes off by heart. Probably some of you did too, Not because I was clever, but because everybody did. I probably knew at least 5 prayers off by heart as well. Not because I was holy, because I most definitely was not, but because everybody did. How many children come into reception knowing 20 memorised rhymes? Any? No. When I was 15, I probably knew at least 10 phone numbers off by heart. Why? Because I used to run home from school and phone all my friends before my parents got in from work. You probably remember those days. I never looked up any of my friends' phone numbers. I don't think I'd have even known how. I actually can still remember some of those numbers. It's extraordinary. Put up your hand if you can say with complete honesty that you know more than 4 mobile numbers off by heart. The words "get a life" come to mind, but the fact of the matter is that actually you don't need to know mobile numbers off by heart. When I ask the 15-year-olds I teach for their mobile number so we can make arrangements to meet and so forth, in order to give me their own mobile number, they get out their phone and click it on. I say to them, "Don't you know your own number?" They're like, "No, why would you?" You know, and if there happens to be a girl in the class who does know her own number, they're like, "Loser." You know, I mean, the fact of the matter is you don't need to memorise these things. Routinized memorization is no longer part of daily life in Britain. Children are not routinely memorizing things as part of daily life, nor are you. And that is a massive problem for us in education, because memory is intrinsic to what we do. It's not the whole of it, it's not even a small part of it, but it is a key part. You actually need children to know their number facts. I need them to know that 78 and 22 is 100. I need them to know their tables. Now, let me ask you, do you teach the times tables? Aren't you fed up of going into the pub in the evening and people saying to people, "Well, you know, what do you do? I'm a teacher." "Oh, I think they should teach their tables. It's terrible they don't." We do teach them their tables. We have never not taught them their tables. We've always taught children their tables. Now, we work really hard to do it, don't we? You've got websites, you've subscribed to this site and the other site to get the practice. They're doing tables at home, you do tables assemblies, you're swinging from the chandeliers, you're doing what you can. You're doing all of that to get them to learn their tables, aren't you? Is that true? Yes. But if I come into your year 6 and I go, "How many 3s in 21? Will 100% of them give me an instant answer? No. So the fact of the matter is that memory, unlike in Shanghai and Singapore, is our short suit. And we have to remember that, because a system that works somewhere else may not work here for that reason. There is something called a forgetting curve. This is usually discussed in relation to sport or music education. And basically, this is content, this axis, and this axis is time. And what happens is that I teach something, so I'm teaching it up here. It could be a ball skill, could be scales, could be whatever. And then if I don't teach it again, gradually the children forget it. Now, the key is to teach it again at the point where they haven't forgotten everything. Obviously, the later I leave it, the more I'm going to have to reteach. You with me? So we have to bear in mind this forgetting curve, because if we only teach addition and subtraction once a year, it is unlikely that children will remember it. That is unlikely to work in Britain. On the other hand, you may want to spend longer on something, and I do think that that is a very valuable thing to do. So I do have a proposal to put to you. There are some downsides, there are some upsides, there is some evidence that this works very well, one from the National Numeracy Strategy and 2 from a recent paper from the Institute of Education. But it is kind of up for grabs, and schools are being slightly pressured on this issue. And so I have a proposal. If you're going to work in blocks, I think 3 things are important, really important. The first is that we actually do need in Britain shorter blocks. We cannot do 5-6 weeks on addition and subtraction and then not teach it again for 2 terms. That didn't work in the 1950s, it isn't going to work now. So that's just not a good idea. So shorter blocks are better. It doesn't mean you can't block, but it means think about the length of it. And there is another reason for that. Come on. As my Year 6 colleague said, he said, you know, if you try teaching 3 weeks on decimals and fractions to Year 5, you all lose the will to live. That is a fact. And I think that's true, isn't it? You know, actually, it can just be boring. It's just not exciting. So there is that thing. The second thing, I think, and this is, to me, really important, you need to tailor-make your blocks. In other words, the only person who can say when you should move on or whether you should spend another week on the topic is the teacher. And that's because it depends on the children. So, introducing decimals in Year 4, you know, which we've just done, you introduce decimals, you do everything you can to teach it well. I get a big piece of paper and we tear it into 10 strips. You're holding a big piece of paper, you're holding 3 strips, we've got 1.3, you know, it's all very visual. We're doing a lot of practical work and I'm introducing decimals. I'm working really hard to make sure they understand because decimals are hard and Year 4 they're only 8. It's a young age to introduce them. So there I am. At the end of a week, what am I thinking? I'm thinking, well, probably they haven't got as much as I'd have liked them to have got. On the other hand, we have got something. You know, let's not jump off a bridge. We have learned something. You know? Do you know where I'm coming from? But what I do feel is that on Thursday and Friday, I was pushing water uphill. Do you know what I mean? And these children, actually, I need to leave it for a bit and then come back to it in another 6, 8, 10 weeks because they will have matured. And Piaget was right. There is something about readiness. I've put it on the table. It wasn't a waste of time. I've put it on the table. But if I come back to it in another 6 or 8 weeks, we'll be able to have a really good go at it. If I go on doing it now for another 2 weeks, we will all lose the will to live. And I'm not going to gain anything. Now, the following year, teaching Year 4, it is possible, I've got, you know, no summer birthdays, only 4 boys. It's possible that I've got a group where you can move on. You know what I mean? You can. I can actually say, right, we'll spend 2 weeks on it. It depends on your class. It depends on your school. It's not going to be the same year on year, even if you're teaching the same year group. So the only person who can say, I've done 2 weeks on this, I need to move on. I've done 2 weeks on this, I actually could do another week because we'd all benefit, we're really getting somewhere. The only person who can make that choice is you. No one else can make it. There's a problem about primary education and it is this. One size never fits all. Anyone who thinks that one size fits all is sadly mistaken. It might work in Shanghai or Singapore, but it does not work here. And that comes back to the reasons which we started with. Diversity and an expectation that education is not something done to you, but something in which you participate. So it is very unlikely that one size will fit all. It is the case that we are redoing the Hamilton site. This is not something I wanted to do at this stage in life, but it is something we are definitely engaged in at the moment. And the way we're redoing it is we're going to make it so that people can choose their own length of block. So in other words, you might log in and you will see Year 3, Term 1. And it will say addition and subtraction, place value, multiplication and division, shape. And that will be what I know you have to cover this term. But then when you drill in and you click on addition and subtraction, it will say Unit 1, you know, adding 2 two-digit numbers. Unit 2, column addition. Unit 3, adding single-digit numbers to 3-digit numbers. Unit 4, you see what I mean? And so you might think, well, I'll do Unit 1 and 2 and 3, and that will take me 2 weeks, and then I'll click on place value and do place value. And I'll do Units 1 and 2, and then I'll click on multiplication and division and do Units 1, 2 and 3 from multiplication. Now I'll go back to addition and subtraction. You can do whatever you like. The only thing you can't do is teach Unit 5 before Unit 1. That won't work, because progression is through the units. But as long as you pick, you can choose your block size. So you can tailor your curriculum to suit your class, which to me is sufficiently important to want to redo the way Hamilton is working, because I think it's so important that the teacher makes this choice. So shorter blocks, tailor-make your own blocks. And the third thing is starters. If you are blocking the curriculum and you are going to do something for quite a long time and then not revisit it for quite a while, maybe next term, then it means that you have to keep that skill simmering, which means you have to do it in the starters. People tended to junk the starters, or if they do a starter, they tend to make it the topic of the lesson they're doing. No, because if I'm not going to reteach addition and subtraction until next term, I've got to keep those skills in their heads. And the only way I can do that is in the starters. So your mental oral starters become very important for two reasons. One, because if I'm teaching counting up subtraction, I need to do starters on counting back subtraction and rounding and adjustment and place value, so that I can give them the choice. Remember the Metaskills. The starters enable you to give a choice. And secondly, they enable you to keep skills simmering through the year. They become much more important if you are teaching in blocks. So yes, it is an interesting discussion. It's one which will be a very interesting discussion in the pub over a couple of pints. But actually, it's hard to say there are any right answers. The right answers have to be created in your school. And that does, once again, put the teacher at the heart of the process. I have never thought the teacher was not at the heart of the process. I've always believed that the teacher was at the heart of the process. So I'm going to finish with one little story that I always tell at the end. So I apologise if you've heard me talk before. And it might be a little bit boring, but it comes back to this notion of play. Some years ago, I should imagine it's even more years than I think, I was doing a talk a bit like this in Coventry. I do not want to offend anybody from Coventry. I'm sure it's a lovely city. But I can tell you this, it's a terrible city to cycle through because there's a lot of motorways. And I was going to this school and I got lost and I could not find the school. This was long before the days of sat-navs. And so I was very stressed. Finally, I found the school. And all the kids were pouring out of school, you know. It was the end of school time and they were all pouring out. And I'm pushing my bike through the playground in a very stressed state. And this 7-year-old stops me and he says, "Are you the maths lady?" I said, "Yes." He said, "Do you want to know something?" I think, "No." I can honestly say I really don't. But anyway, I said, yeah, go on. He said, if you start with 2 and you go right on doubling, eventually you get to 1024. Wow, that's amazing. He said, "I learned that in bed." I think that is fantastic. I think that school should get outstanding on that alone. Because the fact is, I was the sort of kid that doubled numbers just to see what happened. And the fact that that child is wanting to know what happens if you do this is fantastic. Absolutely fantastic. We started by saying there were some things we can be very, very proud of in relation to English primary education. Kids enjoy primary school. They are treated as people who are participants in the educational process. And we have diverse classrooms. Those things mean that we have to create the way we teach maths to fit that. And that, to me, is really, really important. I'm not going to hurry off, so if you have questions you want to ask, then please feel free to come and find me, because I'm not hurrying. Thank you very much. You've been a very good audience.